This is a video all about the process of completing the square. I want to show you a visual demonstration of exactly why the process that you use works. So we're going to look at a specific example first of all, and then I'll show you the general example in a minute. So I've got this function, y equals x squared plus 6x plus 10. And like I say, it's going to be a visual demonstration. So what I'm going to do, I'm going to think of this x squared term as literally a square, where the width is x and the height is x. So therefore the area of this is x squared. Now, this 6x, I'm going to think of that as being two rectangles. One with an area of, both of them with an area of 3x. One of them I'm going to place here, where its height is x. Therefore, its width would be 3. The other rectangle I'm going to place down here, where its width is x. Therefore, its height is 3. So both of these rectangles have an area of 3x. So you can hopefully see how this is starting to take shape. I've got my x squared term, I've got my 3x term here and my 3x term here. You'll notice that the 10 isn't part of this yet. So I'm just going to keep the 10 separate over here for now. We'll think about that in a minute. What else do I have here though? Well, there seems to be something missing. This part here. This is a square. Its width is 3. Its height is 3. Therefore its area is 9. You can kind of see how this process is getting its name, complete the square. There is a square missing. Because we now have one big square, if we include that 9. And the big square has got a width of x plus 3 and a height of x plus 3. So therefore the area of this whole square would be x plus 3 all squared. X plus 3 times x plus 3. However, in my original equation I didn't have that 9, so I need to take away the 9. But I do have the 10. Therefore, this can be rewritten like so. And just to prove it's the same thing, if we expand out these brackets, we're x squared plus 3 times x is 3x. We'll have 2 of those because the 2 sets of brackets, that gives us 6x. The 3 squared is 9 plus the 1. So we'll get x squared plus 6x plus 10, which is the same thing as what we started with. So hopefully from this diagram you can kind of understand firstly why it's called complete the square, but more importantly why we have this process of splitting this splitting the second term, the x term, in 2 to get 2 rectangles, and why it is then that you need to subtract this number squared before adding the term on the end there. Just to do this generally for you, so this is our general quadratic. Again, we've got our x squared here. I'm going to split the b in 2, so I will have a rectangle here where its height is x and its width is b over 2. The same rectangle here where its width is x and its height is b over 2. So the area of this rectangle is b over 2x. The area of this rectangle is b over 2x. we can see that we've got our missing square here, where the area of this would be b, because the width is b over 2, the height is b over 2, so the area would be b over 2 squared. We've still got our c over here, and therefore the area of this square, the width is x plus b over 2, the height is x plus b over 2, so the area would be x plus b over 2 squared. We don't have this square here though, so I need to subtract that. And I've still got my c over there. And this is pretty much the first equation I showed you in that very first video that we looked at. So again, I'm hoping that this visual demonstration will give you an understanding of why we do this process of completing the square, and hopefully make you a bit more confident in your ability to do it.